need you. Okay, so yeah, let's just introduce myself a little bit. My name is Kuemmel. I'm project manager and I did a lot of MicroStream projects as a project manager in the last 4 or 5 years on different companies, and therefore I think it's a good choice that I could do the training for you. If you have any questions, feel free to ask. This is important, and I'm pretty sure I could answer most of them. Let's have a short look to the timetable. So we start at 5, so then we will do 2 hours. Then we have a short break for 15 minutes, and then we have some more 3 hours, and the last one is more the Q&A session. I'm not sure if Marcus or Florian will join today, but yeah, if there are any questions, you can also write me and send me an email, and then I will answer that within that email. Let's go through the topics for today. I usually start with a warm-up project exercise for 2 reasons, especially for all you guys that have joined the fundamentals training, just to see, okay, if there are some further questions or if everything is clear. And some of you joined without the fundamentals training, and then I will do to summarize all the topics of MicroStream and stuff like that. Then we step into some more advanced topics for the configuration of MicroStream. There are 3 or 4 different methods, and maybe some more with all the Micronaut and Helidon integrations. But in that case, I will cover the most important ones. Some possibilities how to configure this, and then we start to talk about some advanced storing techniques, especially eager and lazy storing, and what that means, and transaction stuff, and how to roll back data. I think I talked a little bit about that also on the fundamentals training, but yeah, to be more detailed now in the advanced training. The most important topic for today is for sure the lazy loading topic. There are also 2 reasons for that. You have to understand the lazy loading mechanisms, and also the lazy loading stuff influences your data architecture or your data structure a lot, because you have to find the right balance between having lots of references within your project or having the data within the RAM. And therefore, it's important to know how to use lazy loading and what's the best data structure for using lazy loading. That's an important topic. So we do a lot of research on that. So I'd like to do a research together with you on that topic. So I normally use the Visual VM tool to see, okay, what's going on within the RAM and how many objects we have in the RAM and stuff like that. That could be very interesting for today, and I would say it's the most important topic for today. Then we also talk about legacy type mapping. That's also a huge question always. What happens when my classes are changing, and how can we handle that, and stuff like that. That is covered by the legacy type mapping. And there is one topic missing. I also want to talk about backup, how to create backups, and what are the best practice handling backup stuff. And last but not least, we have a lot of question and answers in the end. I think that's enough for today. Let's see how to go through all that topics. Some informations. Sessions are recorded. The same for the fundamentals training. I promised you will get access to the recordings afterwards. That's for sure. Access to the code. Every project which is handled within that training will be also available on GitHub. So I always share the GitHub link for you. I think every project which is in the training is also available on GitHub. the first link, the MicroStream documentation. Let me just share that right now. So this is the link to the newest documentation of MicroStream. You could find this in the chat, the link. The next link is the GitHub link of MicroStream. Let me also just share this right now. So here we are. That's the GitHub of MicroStream, where you can find also a lot of example projects and further information to MicroStream. And last but not least, the last link is my GitHub repository, where you can find all the stuff of the fundamentals training, all the project of the advanced trainings. It is just a second. So here we are. Yeah, that's my GitHub account. So yeah, you will get access also to the projects more detailed afterwards. But these are the most important links I'd like to share with you. Okay. There will also be a certificate of the course, and I will share the link with you. There's a small form. You have to fill out the form, then you will get a certificate of that training, and also all the information, the link of the video and stuff like that. And yeah, as I said, I will tell this to my colleague, and they should send you the stuff to the fundamentals training. Okay, just to summarize, MicroStream at the beginning a little bit. What is MicroStream? It is basically a Java framework. Nothing more. So basically, it's not a database. It's more a Java framework to store data. And it's a from scratch invented object graph serialization. That means we don't use the normal Java serialization. It's totally new invented. And so we are basically able to serialize an object graph. But in the end, yeah, we are able to update the serialized data partially. And I think that's the important part. So that means there is an object graph, and we serialize that to many different store targets, like you can see that here: file system, AWS S3, Kafka, and a lot of relational databases, DynamoDB, Redis, Azure, and many more. And at the end, you will able, when you change something within the RAM, MicroStream just serialize the changed part directly to the binary file. So at the end, it will be a binary format, and that could be updated partially. Keep most of the data in memory, except the lazy parts of the graph. That's also important. A lot of people ask always, okay, is it necessary to have all the data within the RAM or in the RAM? And you will be able to set lazy parts, and I will come to that later in the training. There is no data mapping anymore. So because, as I said, it's a Java framework, so there is no database server on another side. So and that's also the reason why we don't have to create any database structure, I would say, or a second structure on the database side, and we don't have to do some OR mapping, for example, or any mapping to any other data structure like JSON or to any other format. We don't have to map data to any other format, and that's why there is no data mapping, no mapping annotation, just the pure POJOs. That means the data structure within your project is the same structure on the storage side. There is one question: will the whole graph also saved on the disk? Yes, that's right. The whole object graph is on disk or on any other system. So yeah, that's right. Okay, so as I said, we will do a small warm-up project. And for that, you can do this within your own IDE. You will find one starter project on GitHub. Let me just share the repository with you. There are some. Here it is. Mouse here. It's okay. This is the. Oh, there is an. Oh, again. So the HTTPS. The H is missing. So this is the link to the project. And just start. There are a few branches on that project. So let me just check. Hopefully there is. GitHub has also some issues today. So okay, here we are. So, and as I said, so this is the project on GitHub. There are some more branches, and the first and important one is the start exercise here branch. That means in that branch, most of the classes are empty. So that enables you to add your code to initialize the storage manager and stuff like that. And within the master branch, everything is already done and it's working. And you can just have a look on this, or you can start on this and try it out to find, okay, how is your knowledge of MicroStream? Okay, so that's the project. Let's go on. As I said, start at the branch, start exercise here, and complete the following classes. Let's go first to the storage, package. There is one class which is called DB. This is the class where you can initialize your storage manager, where you can initialize the database root object. Then you have to complete the controller classes. And in the controller class, let me just have a short look to that branch and to the class itself. So as I said, there are, let's go here, main, MicroStream, yes. So there is one DB class, it's looked like this, quite empty. And there is one controller class, and it's a brand and a car controller. So, and within the class, there are these empty methods here, and you have to fill the methods with your code. And you have also to fill the brand controller class. Only two methods in the brand controller. The domain classes are still in place. So that means the data structure is still in place. Let's jump into it. So we have a company, entity with name, and a list of brands and a list of cars, and some smaller car entities and a brand entity. Really straightforward. So entities are available. So as I said, complete the following classes: the controller, the car controller, the brand controller. I would recommend to use the builder pattern to initialize the storage manager. You can have a short look to documentation. There is one example, you can use that. Just set the channel count to 2. And the storage target should be data, the data folder. And that's it. It's a Micronaut project. So that means just check it out. Basically, you should enable the annotation processing of your IDE. That's the only thing. And then you can, I can show you how to start this. So for me, I will work on Eclipse to start that, but it's up to you to use any other IDE. It's working also great. You could use Jakarta also if you want, but then you have to create the project from scratch. So that's for sure, but it's up to you. And you could also just copy the classes from the Micronaut project. It's up to you. But yeah, for me, I'm not able to help you on that. So I could not guarantee that that will work. But yeah, basically it should work. Okay, any questions so far? So let me just go a little bit. Okay, let's stay there. That's a good question. I will go through together with you, yes. So, but you don't have to share it. So, but after that, I will go through the classes and I will explain a little bit so that just to summarize MicroStream. Okay, so let me just share this page again. Okay, so let's say now it's in my Central European time, it's 5:26. Let's say 15 minutes, maximum 20 minutes, and then let's go through the project together. If you have any question, just feel free to ask. Could I import this with Eclipse 11.1? Yes. I'm also working on the Eclipse IDE. And that's the project. And this is the start exercise. And it should look like this. So as I said, this is the empty DB class. And here we have the two controller classes, brand controller, car controller. Yeah, it should work. Definitely. So as I said, you should check if the annotation processing is enabled. You could find this on preferences, and then let's check annotation processing. And in my case, it stays on experimental, and that's okay. So that should work. Okay, so now it's your turn. So let me just share this a little bit with you, just to help. I think on that link, you will find the configuration stuff, and there is first there is the dependency you will need, and directly here we have the way to initialize a storage manager. And this is the builder pattern way I've talked. So you could find some more stuff. There is some more helpful stuff. Yeah, the getting started. This is the root instance we talked. It's an additional class. Oh, not sure if the root is already in place. So especially in that example, just use the company class as root class in that project. So that means the company class is the root object for the database. Yeah, this could be quite helpful for you. So that means we need one instance of the company within the DB class, and with that instance, we are able to start the storage manager. So that means so yeah, I think that this will help a lot. Together with the root object, you will be able to initialize the For those of you who joined a little bit later, we do a small exercise. And you can check out the car exercise, which is in the chat. The URL of the car exercise, I will post it again. Just check it out from GitHub. So if you need some help, you could also switch the branch. And yeah, the master branch, I guess, should be fully filled. Okay. So just a second. Need to find the right page. Yeah, here we are. Okay, this is again the link for the car exercise, and this is again the page of the description. So I think it depends a little bit on how old the MicroStream version is. So there are, yes, not that much changes within 7 to 8, I would say. So especially for the training, 7 is totally okay. Most of the projects I use in the training are already updated to 8, but I guess especially this one is still on 7, I guess, 7.1. But it's not necessary to have 8 in that project. But there are no breaking changes in it. So you can just switch directly to 8 or from 7 to 8. There shouldn't be any issues. So again, for those of you that joined later, we do a small exercise, a warm-up project. You see the description of the exercise now. The link of the project is also available in the chat. So let me just share this again. Oh, okay. So let me just okay. So what you can do, or how should you do that? Just switch to the Git perspective of Eclipse or Eclipse, and then just copy paste the URL of the project itself, and then say use this button here, clone Git repository, and then it will be filled automatically, and you will be able to check out the project. And if you have the project here, you could say, okay, right click on it and say, okay, import project. That should do the trick that you can see the project on the project management here. And if not, if there is no project in the end, you could use the file and go to import existing projects into workspace. Let's click on next, and then you have to browse on your here, and then you can choose the car exercise here. You can directly choose that project. It's the same like it's the same like clicking on right-clicking here and say import projects. That's the same. When you have it in Git, then just try to right-click on it and say import projects, and then it will automatically add it to the project management. Arthur, recordings will be available. Yes, you will get an email with a link to the recordings after the training. But it's important to fill the form. I will share you at the end of the training. So just fill out the form with your information, then you will get an email with all the information you need to see the recordings and and the informations. Great. So, yeah. So this is the description of the exercise again. And as I said, the documentation of MicroStream. Let me just switch. Where is it? Here it is. It will help you a lot. Especially the getting started section will help a lot. And also the configuration. And you can find the methods that can be used to initialize the storage manager. There is some small detail is missing here, so it's important to add something here. So maybe you mentioned it already. But we will talk about that later. So when you imported the project and if you want to start it, you can use so in my case, in my IDE, I have to enable, let me, how can I move this? Okay. So on window preferences, especially in RapidClips or Eclipse, you have to find the annotation processing property and just set it to experimental. That's enough, and that enables you to run Micronaut project. And this is what you need, and then you will be able to go to the application class and just right-click on the class and say, okay, run as Java application. This will start the project. And you should see this here startup complete and server is running on localhost 8080. That's what it should look like. What it should look like. Oh. And it should work in the same way on IntelliJ and all the other IDEs. So let's say 5 minutes left, and then I will go through the project together with you. Three minutes left. It's like a test. Then I will control your code, and we will see if you get an A or F, or a 1 or 6 in German. Oh, okay. So I switched to the master branch. Maybe that's not like me. Okay. Oh, okay. Interesting. Java long reflect field sets accessible Boolean. So you could try to do a fully, so have you, so maybe an update project and just try to force update of snapshot releases maybe. That sometimes does the trick. So do this force update. Maybe a clean could helpful. So let's try a clean to clean the project. Stuff like that. It seems that's only a So let me just check if this is working great for me. Yeah, no issues so far. So POM XML, this version 8 should be. Yeah. I already updated it to version 8. You could see this. I used the 2 dependencies, not only the storage embedded dependency. I also added the storage embedded configuration, but this is not really necessary. So you could also run this without the configuration. That will also work. Okay, so let's get into the project. Let's check the DB class. Okay. For input string H on the relic 16. Okay. Did you try to do this on the master branch or on the start exercise here branch? Already build a Java build on project. Okay, let's check if there is if there are any issues in it. Okay, so we need the dependency here. So we have the two dependencies, and as I said, only this one is really necessary. But this is still in place. So let's start on the DB class. This is what the DB class should look like. So we have, as I said, the company is our root object in that case. So we don't need a synthetic root object. In that case, I use the company directly. It's the root. And we need one public static embedded storage manager here in that class. And I use the static block here to initialize this storage manager. There are many different possibilities to initialize the storage manager. I would say it's totally up to you to create this in your way, I would say. But I think the important part is we used, as I said, we used the builder pattern. So we use the embedded storage configuration that it enables us to set the channel count and also to set the storage directory. There is another method which is called set storage in user home. That's also possible. And out of that configuration, we create a foundation. And based on that foundation, we create the embedded storage manager. And this is what is the missing thing in the documentation is you have to add the root object. You hand over the root object here, and then to call start to start the storage manager. That's important. Okay, that's it. So there is no more in that class to do for us. That's enough. As I said, the domain objects are still in place. The company, our root object with the company name and the list of brands and also a list of cars. Really straightforward, nothing special in it. Let's just have a look to the car, which is also already filled. It has the brand in it and the brand object itself. As I said, nothing special. So let's move on to the car controller. Okay, so first we get the car controller. We get to the car controller via /cars at the end in the URL. The first method is get all cars. That's also nothing special. We say, okay, DB for our DB class, give me the root object, and get cars, give me the cars out of the root object. That's it. Then we have two additional get methods here. The one is by model and by brand. And especially in that case, normally for the training stuff, I normally use only the easiest get methods. But in that case, especially for you to see how it should look like at the end. So by model, and then we are able to add an additional value, to hand over a value. And in that case, it's the model itself, or it's the brand in the method above below. And this is the way we query things within MicroStream. So we use the streams API, and that's what I've done here. So I say, give me the cars, stream over it, and use a filter, and say, okay, give me the model equals ignore case, the model which is hand over within to the method. And in the end, I want to have collect a list. Collect this to a list, and this is exactly what we want to have. This is the return value, a list of cars, and it's straightforward, the same in the method below. Then another method, the delete method, so which deletes all the elements within our database, especially the cars. So let's delete the cars, and therefore we just say, okay, we go again to our root, and then we say, give me the cars. It's always the same. Give me the cars, and I say clear it. And here we have the first store method within MicroStream. And I always have to say, within MicroStream, it's important to store the object which has changed. And in our case, we changed the collection of cars because we removed a lot of cars in that, or we cleared the collection, and therefore we changed it. And this is the reason why we have to store the collection itself. So imagine when we change an element, let's say we changed a car, for example, we changed the model, for example, then we have to store the car itself because we changed it. So, but in that case, we changed the collection. Of course, we deleted a lot of cars, but we changed the collection within the storage. So we have to store the collection, and we just return an okay, cars cleared successful. It's the same on the insert. So let's insert a car, and especially in that case, I used a data transfer object. So that means I used the car itself as a data transfer object. This is not the recommended way to do this, but to keep it short and a little bit easier, I use the car object itself. So, and what is the DB root? So, okay, I try to find if the brand is still in place, so that I can choose the brand. In that case, okay, so if the brand is present, so I say, okay, give me the brand, and then I create a new car. I set the brand, which is already available, and then I set the model based on the data transfer object. And then I say, give me the cars, and I add the car here to the collection. And at the end, I say DB store manager dot store the collection. It's the same. I explained. I changed the collection because I added a car, so I have to store the collection. And in that case, I return the car. In case that the brand is not available, nothing happens. So I think that's the point in that case. But I'm fine with that. Okay, there are two questions. The first one is, how fast is this method, DB store manager store get cars, when we have 1 million entries? Would you say we add 1 million entries, or if there are still 1 million entries in it? Okay. So we added 1 million and both. Okay. So, maybe you will get an answer a little bit later, because we will do that in one of the next projects. So we will add 200,000 objects, and then you will see how fast it is. So let's wait a little bit. Another question: is there a need to synchronize the collections? Basically, yes. So it's the concurrent stuff. Yes, you have to take care about concurrency, basically. But this is the topic for the next advanced training. So, but maybe we have enough time so I can get a little bit into it. Okay, I just have to let some more attendees in. Okay. Any questions so far to this controller class? We have an insert, we have a post. Let's move on to the brand controller. There are two similar methods in it to add a brand. Yeah, these are just examples, nothing special, I would say. What about a test for our controller? That's up to you. It's not. I think it's not. It's not that important. That is Micronaut stuff. It's not covered here within the training. But we can start it. Let's do this. So my storage is not available, so it should be there. So let me just start the application itself. So application is up and running. So in my case, I use the Postman because there are some. Just a second. Yes. We do this. Get all cars. Get all brands. Okay. Insert a car. Okay, so let's check it out. So here is my Postman. So I used 8070. Let me just check if this is also. Yeah, it's 8070. You have to be careful. There is there are some additional lines within the application YAML file. So show in System Explorer. No, sorry. Open with text editor. So you can see this here. There is I changed the port of that application because some of you have some stuff or servers running on 8080, so it makes more sense to have that on 8070. I changed that, and therefore we also have to use this port on. Let's just click on send, and as you can see here, we get an empty array, and we had to wait a little bit because the MicroStream initialization needs a little bit. But now when we click again, it should be much more faster than, but there is nothing in this. So let's first add a brand. So let's say I will use this post method here, insert a brand. So it's a raw type. I use JSON in that case, and this is one brand. Let's click on send. There is one. Let's add another one. Let's say Audi, for example. And let's add, okay, so get all brands. This is also should also be the get method can be called via browser. So Oh, yeah, we have to change the port and give me the brands. Okay, now you can see these are all the brands we added. Let me just check your questions before I go on. Even if I'm adding one new instance to a list, I'm still storing the whole list of items. Is this practical regarding the performance? You will not store the whole list. MicroStream does the thing behind the scenes to add the new entries of the list at the end of the storage. Yeah, definitely. So there is the example project is using the Micronaut framework. It might be different than the Spring annotation. That's right. It's definitely different to Spring. So, but as I said, you could use the master branch. It should be everything in place, and then go to the application and then say, okay, let's run as Java application. And as I said, you have to enable the annotation processing. That is absolutely necessary. And then you will get this this line, this output here. The server is running, up and running, and you will also see the URL, which is important for you. And if you don't have that Postman stuff here, just for the get methods, you can use your browser. Let me just give you that small example. Let's say 8070 cars, I guess. Yeah, it should, in the end, it should look like this. So when you call localhost 8070/cars, you will get the information like this. And in my special case, I already added brands. So let's say, give me the brands, and you will get the brands with what I added before. So, and let's insert a car. So, and as you can see here, one car, which consists of two properties. One is the model, one is the brand. And in that case, so maybe that helps you a little bit. So let me just share the JSON for you. So this is the JSON for the creation of a brand, and this is the JSON file for creating a car. That maybe helps you a little bit. So let's add this car. Let's click on send, and we will get a 200. Okay. Let's add another one. 5, for example. And let's say 8. Let's choose an Audi in that case. And now we should be able to see some of the cars. And let's do this in the browser. Cars. And now you will get the cars. Let's summarize this a little bit. For some of you, it might be new content. Okay, what about that project? It's a Micronaut project. Some classes in it. I'm on the master branch. I already shared the link to my GitHub repository. There is one class in it, which is the master class for the storage, I would say. I called it DB. And this is the class where the storage manager is initialized and where my root object is initialized. And that's important because I have to hand over the root object during the startup of storage manager. So when I create a storage manager, I have to hand over the root object and I have to say start. And that's the point where MicroStream begins to work. So that means the storage manager is our database itself. And then we have the two controller classes, car and brand controller. Of course, there are some domain objects already in place. As I said, the company is our root object. And then we have within the company, we have a list of brands and cars. And I tried to get the right answer for, there was one question, storing the whole list. I'm not sure if I get it right, but just let me get to the car controller again. Did I miss something, or just let me share the GitHub link again. So this is the link again, the car exercise. With a new brand, the brand is not directly visible when calling on brand endpoint. Yeah, that's right. When inserting a new car, yes, they are linked. So you can see that within that code here. So when I hand over a car, a data transfer object, which is the same car object. As I said, it's not the recommended way to do it, but normally you should create a special data transfer object for that. But to make things easier, I use that here. And within the data transfer object, there is one brand in it, right? So I added a car with a brand. And in that case, I check with a filter within the brand if the brand is still available. So, and this is the case here. If an optional, this is an optional. If the brand is present, I say, okay, choose that brand or get it. And then I add the brand to that car. That's important. I don't want to have a duplicate brand within the car. I need the reference of the brand, and that therefore I add the reference to the original brand within the list of brands, I would say. Okay, that's great. Some more question to this example. As I said, it's just to summarize how to work with MicroStream. As I said, it's just a framework. And it enables you to update binary serialization partially. So we added objects to a collection, and we are able to just to synchronize the updated stuff in the RAM with the binary part on the hard disk in that case. And as I said, it's possible to have multiple different store targets. It could be an AWS S3 or stuff like that. And in our case, we used the hard disk, and I can also share this with you. So let's refresh this, and you see here is a new data folder is created here, and you see three different, or let's say you see the persistent type dictionary. That is a really important file. Let me just open this. Okay, this is the type dictionary, and you see every type we used at the moment, or we will use in the future maybe, is part of the type dictionary. So, and when we go further down, you will see our 2 or 3 classes we have in the domain. You can see the company class here. There is the domain class and the car. The brand and the car. And these informations are quite important because this is the object ID. This is the way how we identify an object or the object type within the binary file. So with this number, this object, this is the object ID, which identifies the type car. And that's why the persistent type dictionary is a quite important file, because when you lose this file, you will no longer be able to identify the type or the length of your binary part within the storage. But so that's important. Take care about the persistent type dictionary. And then we have two additional packages here, which is called channel 1 and 0. And the reason why we have two is because we said that we want to have two channels, and two channels means we are able to write down data in two separated threads to the hard disk. This is for that small project. It's not really necessary to have that, but it's just to, just for that example, to add some additional content, I would say. So, and that's why we have two channel folders here. And within that channel folder, we have one channel file, which contains the data, which has the data, and one transaction file which contains the transaction stuff, which is going on the database, I would say. Whenever you write down data to the channel files, the transaction file will track this. So I think that's the basic structure of the data on the hard disk. There is a lot more stuff which is going on here, but this is in detail more stuff for the advanced 2 training. There is another question. The object ID is manually. Yeah, it is. It is. Mostly you are used to use IDs in relational databases, for example. But these IDs are, not, I would say these are not business IDs. It's just an ID to enable the database to keep the data consistent. And therefore, we don't need these IDs anymore, because we use the data relations and the graph relations within Java to keep data consistent. We don't have to have those IDs anymore. And just to find data, choose an identifier, whatever you want. It could be an email address, it could be a string, could be an integer. It's totally up to you. For example, if you need to have a syntactical one, then you can use a UUID, for example. That will also work to generate a special ID which grows more and more. But this is up to you. Most of the time we use UUIDs as a string to create a special identifier. Okay, great. No more questions so far. That's okay. So then I will go on with next topic. Let's have a short look to the different ways to initialize MicroStream. One we have seen is the builder pattern, and especially for that topic, let's move on to the next project. Let me just share this with you. It is called MicroStream configurations. This is the link. Here you can find that project, and there are also multiple branches in it. Let me just check. I think we start on the configurations done branch. That's the important ones, I would say. Just to shorten that a little bit. There are another branches which is called housekeeping example. This is part of the advanced 3 training. We don't need that now. And I think just start directly on the configuration done branch. Okay, so let's jump directly to the DB class. Oh, that's a good question. You have used HTTP response as a return type. Yes. Can we do the same with response entity? I think that's a Micronaut stuff. I'm not okay. You have to check Micronaut for that, the Micronaut documentation. But I think the return type, it could also only be a list, for example. It's also possible. There are many different return types, but yeah, that is Micronaut stuff, I would say. Okay. Yeah, let's have a look to the DB class there. And you see, it's also important to know that you can have multiple storage managers within one project. And I create here in that case, I created a few of them. And as I said, there are a lot of different possibilities how to initialize MicroStream. You could use environment variables, and you could use XML files to configure it. And especially here, let's move on with the first possibility, initialization with an XML storage. And therefore, I created an XML file, which is called microstream.xml. And here you have all the properties you can add. And let me just jump to the documentation also. We can do this. So you could find these properties are, all these properties are possible at the moment. There are a lot of different adjustments that can, or configurations you can do. Changing file names and changing a backup directory, for example, channel count. A lot of stuff is going on there. Just use the names here and add it to your properties file here. And that enables you to adjust those values. Okay, let me just share the property file with you. So this is the link to the properties within the documentation. Okay, in that case, I create the storage directory, which is data. It's the same like in the demo project, and I added a channel count, which is 4. That means we write down data with 4 threads to the hard disk in that case. And I used the ClassPass resource loader. This is also Micronaut stuff to load this MicroStream XML file. And based on that, I initialized embedded storage configuration. I used the load resource get path. And it's always the same. You have to create a foundation first. And based on that foundation, you create a storage manager. And then you say, and then you have to hand over the root one. The root, it was the company object in the example before. In that case, I create a data root, which is not a business object. It's just an object which contains all the lists and all the collections to handle all the different data. And then we can call start. And it's also possible, and I think that's also important to know, to have multiple storage managers that enables you also to store data to different store targets. So that means storage manager 1 could store the data directly to the hard disk, for example, and the storage manager 2 can have the storage within an AWS S3 bucket, for example. So that means feel free to add multiple storage manager if you need it to cover your data on different systems, for example. Okay, let's move on to the next part. This is a short storage initialization. So I would say the shortest way to initialize a storage manager. Just say embedded storage.start, hand over the root and the path to the hard disk, for example, a very short one. This is the one we already have seen. The builder pattern ones, I like this a lot because it enables you to, instead of using the XML stuff, could also be a solution for you, but you have always to change the XML file after or before deployment. So, and with the builder pattern, that enables you to use environment variables, for example, and then you don't have to take care about switching variables before deployment. So you will get the environment variables from the system, and then you will be able to deploy it to many different systems without changing the code, for example. I think that helps a lot. So that is, I would say this is my preferred way to initialize MicroStream. And there is a last one, which is, I think, the most complex one, but it also gives you most flexibility to do some adjustments. But the basic structure is the same, I would say. So we start with embedded storage foundation. We create a new one. So that means we create a new foundation. And within that foundation, we set a configuration. And that gives us the possibility to configure stuff, to set a file provider, for example. We are able to set the channel provider. In that case, we also create 4 channels. It enables us to create a backup stuff, and then based on that we create that configuration, and this configuration goes to the foundation, and based on the foundation we set the root, and then we create a storage manager out of the foundation. It's basically, from the structure, it's the same, but sometimes you have to know that it is enabled in this way to create a storage, because it gives you some adjustments are only be possible on that complex type of initialization. But most of the time, you will be fine with this one. It's totally okay. Okay, you can find all the different types here, also in our documentation. So especially on the document configuration page here. This is one we have seen before. This is the builder pattern thing. Here are some examples with XML files within an ini file, for example, YAML files. A lot of stuff is going on there. So you could find all the stuff on in the documentation also. Okay, so let's start. I created a static method to initialize all of them. And here you can see the initialized storages. And I think there is one which is a little bit more important. It's the storage manager 3 here. It's called the builder storage. And in that case, I create a backup directory. And that could be interesting for you. We talk about backups a little later on, but we can have a short look. So let's open the builder storage. And now you can see we have our channel files in it. That's totally fine. And we have a backup which contains also our channel files. And this is stuff we talk about a little bit later on. But I can say this is kind of like a mirror of the normal storage. This is one possibility to create backups of MicroStream, by creating a mirror like this. Okay, any question to that? There is one question. Okay, maybe I'm getting confused. I'm into Spring, keep forgetting with demonstrating micro. Oh, okay, we've got no problem. Okay. Yes, there is no persistent type dictionary file here because it's just the initialization of the storage itself, but there is no store has happened there, and that's why there is no file in it. I think it should be the same on all the other storages, because, yeah, let's try to. So there are, but normally also the persistent type dictionaries are in place on the storage copy. Yes, yeah, that's important. Okay. So any questions so far? I think that's really straightforward. You can read this in the documentation. Let's move on to the next part and the last part before the break. So if I'm right, then we said that is the break. Give me just a second. I have just to check. Break was on, yeah, okay, 6:05. Okay, so let's move to the last part before the break. And let's talk about the storing data advanced. So that so the basic store mechanisms we have within MicroStream, and therefore just choose the let me just check the exception handling project. I will give you the link to that project. So exception handling, here we are. So you can check out also this project. And let's jump in the branch. Best practice. Rollback implementation done. I think that's the master branch is the empty version in that case, and the rollback implementation done is the branch with all the informations are already filled. So we can directly have a look to those classes. Yeah, just to shorten that a little bit. In that project, there are some special things in it, as for example, that mockup utils. There are some JSON files within a mockup folder down there, just to create some data to play around with. We have our DB class already in place, and as you can see, it's made on the MicroStream XML file. So there is a MicroStream XML file in place. We have a data root class, which is not a business one. So that means just a root object to have all the collections in it. And as you can see here, we have a list of books within the data root. And each book contains the author, the two domain classes here, and we have a book controller. And let's jump directly to create books. Let me just clear book, update book, non-store. Okay, so let's stay on that method, on the first controller method here. So I told you that you always have to store the element which has changed. And the default store behavior is the lazy storer. That means, let's say we have one collection, so we store a collection here, and only the collection itself will be stored in that case. But some of you ask, is it possible to have a store mechanism that stores also all the sub-entities of a collection? So what about to store the collection itself and all the books in it, and also all the authors within the books? This is also possible, but then you have to use the eager storer. And that's the difference between lazy and eager. This is also a topic within the documentation, which is called storing data, lazy and eager storing. Let me just share this page for you. So there is an explanation about this mechanism. So as I said, lazy is the default mechanism. So whenever you use the db.storemanager.store, you use the lazy mechanism. That means you only store the object which has changed, but not the object below. So and it's if you want to use an eager storing, so you have to create an object like this. So so let's say we want to store the collection of books and also each book within the collection. Then you have to create stuff like this. Let's say db.storemanager.create an eager storer. And with that eager storer, that enables you, let's call it let's keep it let's keep the name eager storer. So let's do it like this. Eager storer, and that eager storer enables you to say store, and then you can hand over the object which should be stored, and after that you can say eager storer dot commit. This is the way how to use it, and maybe that gives you a little bit an idea how to use this within a transaction, for example. So instead of using the eager storer, we could do the same. We could do the same to say create a lazy storer. So that's the default one, but it's also it enables you to create a transaction. Let's do it like this. Just copy this. And use the lazy storer instead of the eager storer. That's also possible. So just create the storer which do the best work for you. And but the default way is the lazy storing method. And if you want to have, so there is another word for storing all the objects below, but yeah, I'm not able to find that word at the moment. So, and this enables you to create, as I said, a little bit of a transactional stuff. Some of you might ask, okay, how to use transactions and rollbacks, because these are mechanisms of most of the databases. It's not deep copy, it's a traversion. I think traversion is traversion the right word for it? Storing traversions of an object graph, not sure about it. So I try to find it. So traversive, I think traversive is the right word. Not sure, but yeah. Okay, so I create one example for you here in that project. Let's say we want to update multiple books. So I create just a situation where we say, okay, every book which starts with an A should be more expensive than the other ones, and we add $10 or euros to the price of every book which starts with an A. That's the task we have to do. And in that case, I said, okay, I just want to change the book. So therefore, I just need the lazy storer. And I created that lazy storer and I used the try catch. And then say, okay, let's go through all the books. So, and just remember, I filtered a list of books. So let's see, okay, I say, give me all the books, and stream filter starts with an A, collect as a list. And then with a for each, I go through all these books, starts with an A. And in that case, I say, add a new big decimal 10. And then I say, lazy storer store. And I remember I changed the book now. So I have to store the book itself. And therefore I stored B. And at the end, I say ls.commit. to make it happen, to write down the data directly to the hard disk. And if something went wrong, so I'm able to do a rollback. This will be a part a little bit later on. But this is how to create stuff within a transaction, I would say. That helps you to create, a little bit like a transaction. Most important, some of you might say, okay, transaction is great, is working, it's not that complicated. But what about a rollback? So when we want to roll back data, and this is a part which has changed in version 8. So normally I provided you a class which was called persistence or something like binary persistence reloader. This is not necessary anymore. There is a class which is called reloader within the version 8. And just create an object based on, let's say, reloader.new. And you have to hand over the persistence manager. And with that reloader, you will be able to iterate through the collect stuff and reloads the value from the database and replaces the already changed values within the RAM. So that does the rollback thing. You have to imagine, you always change stuff in the RAM, and then you say, MicroStream, store it. And if something goes wrong, you have to find a way to restore the values within the RAM. And this is done by the reloader. The reloader goes to the database, reads the data, and resets the data within the RAM. I created some additional methods down here. So I created update non-store, for example, or an update non-store deep. And let's check this out if this is working. So give me just a second. Concurrency, back, no, where is it? Exception handling, here we are. Just have to check. There is data is still, let me just delete it. So let's start the project. Where is it? Application. Oh, come on. No. Okay, run as Java application. Changes. Okay, run as Java application. Up and running. Let's just double check the port 8080. That's okay for me. So let's move on to another tab. So we can do this directly in the browser. Just a second. So I think books. Yeah. So I called the books method, and there are no books in place. So let's create some books. Let's say /create. So let's just double check if there are some books available. Now you can see this, many different books. And this, by the way, these are the books which comes from the mockup utils. And I explained that a little bit before, the author and books JSON files. And that's why we have that books here. So I don't know how many, but some of them. And now try to change something. Now let's use, just give me, I closed it, the books controller, and let's use the update non-store. And that this method change the name of the book. Just check, should be this one, right? So yeah, it's the same ID. So it changed the book start gem, the name of the start gem, the start gember to Java the good parts. So let's try this out, books, and then we say update non-store. That should be right. So just copy this. Okay, so name of book successfully changed. So remember, we only changed the RAM now. We didn't store this. So there is no store method in here. And now we could use the rollback flat method. So let's do this. Let's say rollback flat. Book successfully rollbacked. So let's check it out. And you can see start chamber is back again. Let's do this. There is also a possibility to do this the deep way. So let's call the update non-store deep. Come on. It is. So books / update non-store deep. So it changed the author, and the author is part of a book within the list of books. Successfully changed from Firks to John Travolta. And just check this out. So you can see this because the data comes directly from the RAM and not from the hard disk. So the data or the name or last name is changed, but it's not stored. So let's roll back this. Let's say rollback deep, I guess, is the rollback. Successfully rollbacked. Just check this out. You can see last name is Firks again, and that's it. That is the way how to use the rollback mechanism, and this is the same within the method here. So whenever something goes wrong here within the try catch, you can use the reload mechanism down there within the catch block and say reload new and hand over the persistence manager, and then you can say, okay, let's do the reload for each element of the book collection. Okay, so any questions so far? A little bit more in detail how to what is the default storage, the default store method or behavior, the differences between lazy and eager storing, and I think most important to give you an idea how to realize transactional behavior within MicroStream. Yes, that means, yeah, 5 changes is just 1 transaction. So, of course, you changed the elements within the RAM, but you did not commit the chain. So that means ls store. So in that case, lazy store just register the object into the lazy store, and the commit is the very important part. It writes down the data directly to the storage itself, to the persistent. No, there is no automatic commit. So you have to call the commit, or you have to say reload that element. There is no automatic commit. And I think that's an all-over question. There's also a part which is asked a lot. Is there, when we change something, does MicroStream store the element automatically? No, MicroStream will never store the elements directly or automatically to the persistence. You always have to call a store method or a commit method to store it, to save it, or to make a some of you might say this is kind of like data backup. I would say most of you or some of you might use MicroStream for as a cache, for example. Then it's kind of like a snapshot on the hard disk of the data. Store is in the RAM. No, that's not the truth. So this is the line where the data is changed in the RAM. So line 43 changes the data within the RAM. And the line 44 registers the object which has changed to the storer. And at the end, the storer says, okay, now I go through all the registered objects and persist or store them to the hard disk. So 43 changes the RAM, 44 registered the object to the storer, and the commit stores the data on the hard disk. To use MicroStream as a cache, but could not find a possibility to set the time to live. It depends a little bit. When you use it as a cache, do you mean use it within the within Hibernate, for example, as what is the default cache for Hibernate? Is it EH cache, right? It's the default cache implementation, EH cache. You could also use MicroStream for that, and then MicroStream has the same let's say that it's the same implementation like EH cache, but especially for the cache, and it's also, I think it's the same on Hibernate. You have to take care about the cache yourself. So whenever you change something, you have to say, okay, this element should stay in the cache, or it should be cleared. I think that's also a part for later to talk about what about lazy elements and how they work within MicroStream. I think your question will be answered also with the lazy part, which is after the break. Does this save time space on disk? What do you mean exactly? What exactly does save time or space on disk? Maybe during I go to the next question. Should you perform this logic in the controller class layer or better in a service class layer? Yeah, of course, better in a service class layer. That makes more sense. I think it's only an example for you to see how MicroStream works. The basic implementation stuff within Micronaut and how to do the architecture of classes and structure of classes, that's totally up to you. So create another service class to add or your store logic, or create some data access methods or stuff like that. That's totally up to you. I think these examples are only to show how MicroStream, or how easy MicroStream basically works. Okay, so this also saves, of course, it saves time, because instead of doing this, we also could do this, for example. So we could also say db.store or db store manager.store b. This could also be a solution for you. That's the easiest way to store an object. But in that case, b will be directly stored to the hard disk, for example. So that means change an object and write it directly to, and this is handled as a transaction. This is one transaction. But I think that is not the best way to do this, because you have to call store again and again and again and again, and it takes time to do this. And it makes sense to collect all the objects which should be stored on the hard disk and do that only once to store it. That will save time, of course, and performance, because this is a blocking operation, and that will decrease the performance of your for each loop there. But it's basically possible to do this in this way. Let's move on. But first, I want to answer some questions during the break. I will start at the first one. According to transaction itself, does the data will readable by other sessions? It's all about the isolation level, I would say. So the point is that every session or every client is working on the same object graph by default. So that means when you use MicroStream as a embedded storage within your application, then everyone is working on the same graph. And that's the point that makes it so important to have a proper knowledge about how to handle concurrent access to some objects. I think that's the answer to the first question. The isolation level, everyone is working on the same graph. And there was one so without the store method, the object is still detached. No, it is. So that means when you say book.set a value, then everyone is able to see the change of this object. And yeah, that's basically the point. Everyone is working on the same thing, and everyone is able to see that change. And yeah, that's basically the point. So now an important question comes into play: how to handle this? How is it possible to make it or to keep data consistent? And this is the point where the question comes up: how about locking data? What is the possibility to locking data? So basically, you can use every Java mechanism to keep data consistent. Let's start with the word final, for example. Let's use synchronized method. Let's use synchronized collections, for example. All that mechanisms are working on the object graph, and these are, I think that's the first step to keep data consistent. And especially there was one question about let me just check. Will MicroStream will wait until delete process done or stuff like that? That's all about synchronization. So, or using final properties and the keyword final within Java. The second point is, do we talk about technical locking, or what kind of locking do we talk about? So do we talk about what is the first locking, the pessimistic locking, for example? This is an old one. Nobody would use this anymore. Pessimistic lock is, yeah, it's not the best locking, I would say. So most of the time we use the optimistic lock, and this is also the implementation which Hibernate provides, I would say. And you could do the same on your object graph. Use an optimistic lock mechanism. There is no mechanism still in place, because mostly the optimistic lock is not a technical lock. It's a business lock mechanism to keep data consistent, but it's not really a technical thing. But it's important, and you can use it, but it's not part of the database to handle that. So because maybe there are some objects within your object graph which you would say, okay, I don't care. Nobody, there are no conflicts or any problems. I don't need that locking mechanism on that object, for example. So that's totally up to you. You could use any lock mechanism, optimistic lock, whatever you want. Let's talk about the technical stuff. So what about when we iterate through a collection and someone deletes objects out or clears objects out of that? And that is the point where where it is important to use concurrent mechanisms within Java. So let's say the reentrant read-write lock, for example. This is a great opportunity to handle this specific type of product. You can use any concurrent hash map, or there is all the concurrent collections can be used within MicroStream. The good news is it's all about you. You have to define which mechanisms you want to use within your classes. That's totally up to you. Yeah, there are a lot of possibilities, a lot of built-in mechanisms within Java to handle that. And I think most stuff is, I'm pretty sure all of that stuff is covered or can be solved in some ways. There is one, I think, especially the final keyword. The final keyword is the best solution for all properties within a class, for example. So that covers the whole class, or that prevents the whole class for any concurrent issues. So I would recommend to use the final keyword all the time, or especially use what is the new feature in Java? Records, for example. You could also use records within MicroStream, and that solves a lot of trouble, a lot of concurrent trouble, I would say. But yeah, most of the time, I think to summarize that, this is normally a topic we could talk for hours, I'm sure. But this is a part of the Advanced 2 training next week. So there I will give you some best practices for concurrent stuff and so on. Yeah, but yeah, the final, you create new item, that's all, but that covers you from all the changing values within a property and concurrent accesses and stuff like that. That solves a lot. That final, it's a quite important keyword, I would say, within the Java world. And there are a lot of stuff when you search for it, especially when you search for solving concurrent issues within the Java world and within Java objects. Then this will lead you to the keyword final, and that will help you a lot. But that's not everything. So there are a lot of stuff more synchronized, for example. But synchronized, it's not always the best solution, because it blocks access to methods, for example, or it blocks collection. But then maybe the reentrant read-write lock. This is a great solution because it differs from read to write access, and that blocks the that blocks the write access, or that synchronizes all the writes and enables the reads on the other side. So a great solution, I would say. But this is part of the Advanced 2 training. But hopefully I could answer all that questions during the break, depending data isolation and stuff like that. Yeah. I hope that helps a little bit. Log into the service layer, yeah, for sure. Yeah, definitely. So I think so. There are so many possibilities. So the reason why for example, why I use Micronaut within the training is that most of the time, and most of our projects, when we use MicroStream, we use MicroStream within Micronaut or Halidon applications to create data provider applications. So that means in some smaller projects, we use MicroStream as an embedded data storage. That's totally okay for smaller and medium applications, but for especially for microservices and stuff like that, mostly we use Micronaut to provide the data via REST. And then most of the time stuff is totally different because you have that REST layer in between, and that makes things different, I would say. Yeah, but I think that's not the basic topic for today. Let's talk about the next topic, lazy loading. That's also quite important to know how to handle that. Lazy loading. I want to start with a short presentation, just to give you a hint of what does it mean to have lazy loading, and why do we need to store and load data in a lazy way. This is what a lot of people ask. Okay, are I able to store 3 terabytes of data within MicroStream? And basically, I would say yes, it is. You could do this if it makes sense. I don't know, but basically you could do this. Okay, let's talk about this. Next question is what data should be stored and loaded lazily, and how to use those lazy references. What is the in a technical way? So, and we go through some best practice examples, and we do some researches. We will have a look on the RAM side and see, okay, how much RAM does it need to have the data in memory and on the hard disk? How to release lazy data if no longer needed. So that's also an interesting question. How can we release or clear data which is no needed for some time? Stuff like that. There are some projects which are available also on GitHub. So let me just share this directly with you. One project, I would say it's this project covers most of the best practices with lazy loading. There are a lot of different branches with different data structures to see how it basically works. Okay, so let's go on within the presentation. So why lazy references are important? MicroStream is basically an in-memory database framework. That means data stays most of the time in memory. And that is also a reason why it is that fast and performant. That's not the only reason, but it's one of the main reasons why it is so fast. Of course, the missing or the no longer needed data mapping, for example, is also a huge performance impact. But of course, to have the data directly in the RAM makes it that fast and performant, of course. And also the type of serialization and stuff like that. That is okay. That means you will get the best performance when data has to be in the RAM. So, but yeah, you would say, okay, it's not necessary to have all the data within the RAM. And then therefore we need a mechanism to keep data on the hard disk or on the storage. So that's what I'm trying to say. But in some cases, it's impossible to hold all the data inside the RAM. And of course, it makes no sense to have that all the time within the RAM, especially for binary data, for example. That's the same. Some archive data or some historical data, nobody needs this within the RAM. And this is also a topic when I'm talking to people on a conference, for example, they ask, okay, is it possible to take my Oracle database and write all the data within MicroStream? So it is possible, definitely. So, but does it make sense? I would say no, it doesn't make sense. So I think it's more important. The question is use the right store technology for the right type of data. So when you need high performance, when you need the data in milliseconds, nanoseconds, whatever, then you have to use MicroStream. But let the data could stay, most of the data could stay on a slower database, on a slower Oracle database, for example, archive data or some stuff, other stuff. So it makes no sense to write all the data within MicroStream most of the time. It's possible, but it's totally up to you on your needs. But basically, we need a way to decide which data should not be loaded to the RAM on MicroStream DB startup. And that's also important. Whenever you start MicroStream, all the data will be loaded to the RAM directly on startup. So except the lazy data. But let's move on. So this is what I said. So the default whole data will be loaded into the RAM at startup of MicroStream. It looks like this. So let's say we have an object model and storage files on disk. We have, let's say, 100 million objects, and these objects will directly be loaded to the RAM. Yeah, that's the point. This is what it could looks like when we add some lazy references, and especially lazy references are not a type of an object. It's more like a lazy wrapper. We will see that later on, and it looks like this in the end. So when we have a lazy reference here, then you will this data, this whole graph of data will stay on the hard disk. When we load this one, then the 4 will also stay or will still stay on the hard disk. So until we call the get methods on 4, then you will get the data. But this data will stay directly on the hard disk, and it's the same on 4 here. And that's basically how it works. So the question is when to use lazy loading. What is the best practice on lazy loading? I would say use lazy loading always on binary data. So that means blobs, documents, images, stuff like that. Whenever you have huge binary objects or binary objects overall, use lazy loading. That's for sure. There is always a question how to have that. What is the best collection or how to have that? I would recommend to use a hash map, especially for that. So you have maybe you have a description as a key, or a name as a key, or file name as a key, and then you have the binary element on the value side. So this is one possibility. You should use lazy loading always on huge collections with less frequented data. So let's say archive data, logs, and stuff like that. Stuff which is not needed all the time. So keep it on the hard disk. It's totally fine if it's there. So yeah, we don't need it. Sometimes on collection with a huge amount of sub-entities. So this is always a big problem within the world of graphs. We always talked about, object-oriented programming is really great, and this is great and it works fine. But in some cases, it is better to have smaller sized graphs, and maybe to add, let's say, to cut the graph in pieces, to not have the whole sub-entities within your RAM when you only want to show a flat grid, for example, of data. So this is also the problem within Hibernate, for example. You have maybe you have a great Hibernate data structure, but the problem is you could also set lazy and eager endpoints within the Hibernate configuration. But the point is that even when you have lazy data and you want to get the data from the database, Hibernate creates all the time the query, which queries also the lazy parts, and that slows down the query, for example. So that means in some parts, I would say it's more recommended to have smaller graph sizes. Don't create those huge graphs, because most of the time within your application, you only show really flat data. And then in the end, it makes no sense to have all the data in the background, which is not needed to have that. So that means sometimes on huge collections, use lazy loading within sub-entities, or use lazy loading on the collection itself. But yeah, you could do this, you could do whatever you want. Whenever you want, if performance isn't that important, in this part of data model, or the amount of, so of course, if the amount of RAM is limited, then you have to take care about lazy loading. But there is also an interesting question when MicroStream comes into play. So let's say we have a database which is, let's say 100 gigabytes is the size. And then we add some lazy points and stuff like that. And then we start up MicroStream and we see, okay, 100 gigabytes on hard disk. And at the end, we have, let's say, 20 gigabytes in the RAM, or let's say 12 gigabytes within the RAM. That's great, right? So that is on startup. So, but what happened if we have 1,000 concurrent users on that system? Because that all these users will load the data from the hard disk, and then your amount of RAM you will need will definitely increase. So that's an interesting point, because you have to see what happened with the data when the concurrent users are working on the data and all the data is loaded from the hard disk, for example. And that is more important to see that. And that is also when you compare systems, when you say, okay, we need a database here, we need a cache there, and we need a front-end server there where all the peoples are working around and all the users are working around. All these different systems needs RAM. And when you compare that and when you say, okay, sometimes people say, okay, MicroStream needs a lot of RAM, but in the end, you will need the same RAM on different systems anyway, because let's say 12 gigabytes on the cache side, 12 gigabytes on the database side. And then we have, in the end, we have 30 gigabytes on different systems. You have to pay the same, I would say, instead of having one MicroStream server with, let's say, 64 gigabytes of RAM, for example, to have the data within the RAM. But this is a different topic, I would say. Let me just have a look to the questions. Loading includes sub-object in the tree? Basically not, no. When you, so it depends a little bit. If, let's say object one, let's say a customer or a list of customer is loaded lazily. So when you load these customers, then all the sub-entities will also be available in the end. So will also be loaded to the RAM. Except when you add, let's say when a customer has an additional sub-entity, let's say products, for example, or ordered products. And when you add an additional lazy reference, then these data will stay also on the hard disk. Then you will get only the customer data. So I think that's how it works, basically. Okay, so yes, let's move on. So this is the way we basically use the lazy mechanism. So as I said, it's a lazy wrapper object, and within you have your regular object. And this is, by the way, what I'm talked about, how to handle blob and images and documents and stuff like that. That I would recommend you to do that. Use a hash map, and within the hash map we have a string as an identifier, and on the value side we have a lazy reference of bytes, or the binary object within a lazy wrapper. If you only have a single image, then you could do this in this way. That makes sense, right? So if you want to find the right document, you can go through all the strings of the hash map and find the right element, I would say, the key in that case. Okay, this is the way to use it on binary. So this could also be a possibility to have a list of books, lazy list of books. I have to say this is basically possible, and in some parts of your application that makes sense to have that. But are there any disadvantages on that structure? Have you an idea? Why not to do this on huge lists, for example? Some of you? That's right. Whole collection is loaded at once. So yeah, that's right. When you get all or nothing, that's exactly the point. So when you try to find something within that list and you use a stream, you always have to load the whole list And that could be a problem. Not on smaller size lists, that will be okay, but on huge lists or big lists, so you should not do this in that way. Okay, what about this? We use a hash map with some strings as an identifier, and then we have a lazy list of books. That looks definitely better, I would say, because that enables us to create a proper key, for example. That means, let's say we have a list of books on the value side, and we could have the first 3 digits of the ISBN, for example, as an index. And this is always the answer of indexing data. People ask that, how about indices or indexes within the database? And use hash maps for that. You could create your own index within the string, and you can use it as a, let's give me this, you can search for the first 3 digits of the ISBN, and then you will get a list of lazy books, and you don't have to load the whole list of books at once. Okay. Let's stop here. I will come to this a little bit later. So let's move to the IDE. So, but first we have some questions. What about lazy collections from MicroStream 8? Yeah, I come to that. So give me just a second. So we will come to that at the end. We need a good partition key here. That's right. So is there page enabled options for collection? Yes, there is. So I think the question is good when we talk about the MicroStream 8 lazy collections. Unique hash values. Yeah, of course. Okay, so let's do a little research. Just a second. I have to start the visual VM first, just to see the data. Here we are. Okay. So we will need this just to see what happened within our RAM. So we need the right project. In that case, we use the lazy loading demo project. And we start on the first branch. So switch to the master branch. Okay, let's show you. We have a mockup class with a person JSON. That's important. So there is one JSON file, and it contains 1,000 objects, 1,000 persons, and each person consists of these values here, or these properties here. We have first name, last name, male, gender, IP, and these values are, yeah, quite, I would say, small size data or small sized strings. And there are 2 additional value 1, value 2, and these are values with huge amount of a huge string. You can see that here. So you can see that are some random strings within that object, huge strings. So that is the JSON file. And this is used always when we need to create dummy or mockup data. Okay, so person here. So let's go to the root object. So the data root, which contains a list of persons. That's great. You have that. DB class, nothing special, straightforward. And we have one controller class. There is one create method, and this method is available on each branch. And what it does, it loads, it iterates 200 times, and loads 200,000 or 200 times that JSON file. So whenever we call create, it creates 200,000 objects, person objects in the end. This is a method to get these persons, and then we have another method just to init the MicroStream storage, just to see what happened when we initialize the MicroStream storage. Okay, so let's go on. Let's start that project. Let me just check if there is the data is empty. No, it is not. So let's delete the data folder. Okay, so heavyweight data stuff. So run as Java application. So let's access the JVM visual for M. So okay, so MicroStream isn't initialized. So let's create the first, or let's call the first method. Let's call the localhost 8080 create persons/create. So if you want to do this together with me, so you have to call localhost 8080 persons create. So let's check what happened on the database side. So you see, so storing the data, so the data increases, and now we stored 200,000 objects on within MicroStream. So it's done. So you can see the message here: person successfully created, 200,000 in total. That is, let's do a small garbage collection, around 1 gigabytes or around 1 gigabytes of data. Let's have a look on the hard disk side. So let's see how many data we have on the hard disk. Show in System Explorer. Here we are. So okay, let's go to the data. So let's just check if it's already cleaned. So you see that is the data handling in the background. So that is a point which is part of the Advanced 2 training, but it's just a small hint. Whenever you store data, the data is stored in one huge file. So that speeds up the data processing on the hard disk side. But there is a housekeeping process in the background which cleans the data in the end, and you can see that here, which creates smaller sized data files in the end to handle that in a better way, and that needs a little bit. So give it just a second. Now it should be. Okay, now you see this. The huge file is gone, and it is split up in smaller ones. Now we are able to measure the size. So let's measure the channel 1, 2, 3. Let's say, okay, this is the size of the files on the hard disk, 1.5 gigabytes of data. And this is exactly what we have within the RAM. So 1 gigabytes of data. Let's see what happened when we just initialize MicroStream in the end. So let's stop the application and start it again. Run as Java application. So let's delete this one and open the next one. And now I use only the init method to just initialize MicroStream. And now you see, this is what I said. Whenever MicroStream starts up, it loads all the data from the hard disk without lazy loading. So this is basically what it does. Okay, so as I said, it's not the best way to do that. Let's move on to the next solution. Let's move on to having the data within a lazy collection. So let me just clean up the data and go to the next branch, team, switch to step number 1, change to lazy. So the solution is now, it's a little bit different. So we have, as I said, we have lazy list of persons. Let's do this in the same way. So let's start up the application. It's always the same in that on that easy startup completed. Let's call persons. Let's see if there are some persons in it. So no, you can see it's empty now. So let's init, or let's say create the 200,000 elements. The visual. So now you can see we have the same amount of RAM, and if we call a garbage collection, it stays the same. So you would say, okay, we used a lazy now. Why the data stays within the RAM? This is because the default configuration of lazy loading. So, and the default configuration says so if the data is not needed anymore, and we reached 75% of the RAM, of the whole RAM of that JVM, it starts to clean to clear that lazy references. Or if the data is not needed for, I guess, 30 minutes, I guess. So after 30 minutes, the data will be cleared from that lazy list, because it makes no sense to have data loaded lazily when a lot of people use that data. Then it makes sense to keep it in the RAM, because you need that data and you have to work with it. So then it should stay in the memory. So that means we have to wait now 30 minutes. Let's do this and see if it cleans up the data. No, just joking. So let's move on to the next example. Okay. Give me just a second. I want to just, genau. Okay. So let's do this. We didn't talk about that. Just a second. I have to import this and use this one. Okay, so I changed with that line of code 25, 26, 27. I'm able to change the default behavior of that lazy reference check. And especially for this example, I changed the duration to 1 minute. So let's try this. If this is working as expected. Let's start the application again. Here we are. Run as Java application. Let's clean up the visual VM. So, and sorry for that fast jumping around on my screen, but there are so many windows I have to use. Okay, application, oh no, the data is still available, so we don't use that create. So let's use the init method. So let's call init. So that means MicroStream is initialized, as you can see here. Let's have a look to the RAM. And you could see this RAM stays low, quite low, because all the data is loaded lazily, so it stays on the hard disk, and it's not read it by, or it's not part of the RAM. So, but now let's try to load, and now we iterate through the data, and now you can see it increases again. And now we have, after 1 minute, it should be cleared, because this is what we configured in the DB class. So let's just wait some seconds. And yeah, there is one question: is the 30-minute delay configurable? This is exactly what we do now. So, or what we have done before. Yes, it is. I have to say. Just check. Let's do a garbage collection before, and you can see not just a few stuff is, but let's wait a little bit longer. So 45, let's say on 50. Yeah. So after a minute, the data should be gone. Okay. Not now. Okay, we are still on 30. So okay, we are okay now, but now we should. Now you can see that now data is released and it's no longer available within the RAM. So this is basically how the lazy concept is working. So, and as I said, default is 75% or 30 minutes, but you will be able to change that. That is totally up to you, what kind of strategy you want to have within your project. Okay, so, but we all knew that this data route, this is not the best way to do that. So therefore, let's move on to another solution. So let's move on to the next branch and say, switch to, come on. Give me just a second. Yeah. So switch to, change to Mac. Discard changes. Okay, so now we used another approach. I've already shown to you the map, for example. And this is really a great opportunity to store data. And it's a much better solution, I would say. So let's start it directly. It needs a little bit longer to store the data, but oh, come on, what's wrong now? So I need a break, I would say. So let's delete the data first. So okay, here we are. Okay, run as Java application. So okay, let's go to the browser. Data should be empty. That's it. Let's call the create method. We forgot the visual VM. Okay. So now you can see the data size is quite the same. No real differences to using or due to using HashMap or another collection. But now let's restart it so that all the lazy stuff is gone. So run as Java application, and you remember all the data is loaded in a lazy way, so it should stay on. Come on, now I did something wrong. Persons, just a second, I have just to check on the second application what happened there. Oh, come on. Okay. So there is one controller class or one method within the controller to find a specific person. Or oh, come on, I'm on the right branch. Change to map, yes. get person. Okay, I see. That's the reason why the data is why the data is so the usage of data is so slow, or not slow, so small. So because I only load the key set of the person when I call the create method. But just let's move on to the next branch. I think that that is more important. Team switch to multi-maps. So I think that is also a really good solution to, or a really good data structure. Instead of having one collection or one map of persons, you could also do stuff like that. And you can see we have two domain one persons class, and this class contains multiple maps of persons with a different type of key with different type of key. We have one collection which sorts the person by last name, and I would say more precisely the first 2 digits of the last name. And in the second collection, we have the persons by male and also the first 2 digits of the male. What would you say? Does that doubles the amount of data within the RAM? No, why not? That's right. These are always same references. That's right. But there is maybe the keys. Yeah, that's definitely right. The keys are double, and also the references are doubled. That is in some times that could also be quite painful to have such huge amount of references, because each reference needs also a little bit of or a little amount of RAM. And especially when you have, let's say, 100 millions of data of rows, for example, then it could make sense to decrease the amount of references, because this could be quite painful if you have huge amount of objects. And in some parts, I would recommend to decrease the size of those references. For example, instead of using an integer, if it's possible, it makes more sense to use an int, because it's definitely smaller. You should always use primitives if it's possible. So because it's a lower memory footprint. Or maybe it makes more sense to have objects stored as also maybe as a JSON format, instead of having a huge amount of properties. In some parts, we use such a format configuration when we create keys for lazy elements on the value side. So all that stuff could make sense, and it's totally up to you how to store the data. That's what I said. You have to see, okay, the amount of references and the amount of objects within the RAM. Okay, let's create some persons within that structure here, and then let's see what happened within the RAM. Okay, so let me just clean up the storage again, because the structure has changed. And let's start this application. Let me just check if there are some data in it. Completed, not found. Just double check the controller class. Okay, we have the create method. Let's call this. We need the data anyway, so let's create Oh, come on, that needs a long time. That's not normal, I would say. Okay, now, so yeah, that's also a point. So this structure is great for storing data or storing huge amount of data, but of course it needs longer to insert it, because you have to add all the references to the different collections and stuff like that. It needs a little bit. But when we have a look to the visual VM, we see that you see we have 2 collections of persons now, and it's still 1 GB data usage. And when we now restart the project, you will see that when we search for items, the memory footprint will be quite low because of using just the key to search in it. Okay, so, and now let's try to find, I have just to double check so let's try to find a person and say, let's search for the last name. I think there is one person with the last name Koch in it. So persons, search for last name. Yeah, this one. Let's check the memory footprint. And now you could see we don't have to load the whole objects again. It's just, you have just to open this specific hash map value, which contains the right key for the first 2 digits, in that case, K and O. And that helps a lot to create a proper data structure working with MicroStream. Okay, any questions so far? There are some more stuff I want to talk about, but for now, are there any questions? These are the basic data structure I could recommend. I would say this is some best practice. Maybe there are some more and better solutions, but these are some ideas how to create a proper data structure with MicroStream. Time needed for lazy load. So I would say basically the time we need to serialize the data, and then you have to add the time to transfer the data from the hard disk to your application. It depends. I would say it depends on what type of storage you have. When you transfer the data from AWS S3, for example, as a storage, then it needs time. It needs longer to transfer the data, of course. Most of our customers always or mostly use as a primary storage, they use the hard disk or persistent volumes for the storage, and they write down the backup to an AWS S3 bucket, for example, for a snapshot and stuff like that. And that could make sense because it's much faster to load the data directly from the hard disk instead of loading it from a remote server, for example. But yeah, time needed for lazy loading, it depends. Yes, exactly. Garbage collector will automatically jump in. But if the data increases that much, then you will get an out of memory exception. It will try the JVM will try to do everything to clean up or clear the garbage collection and clean also the lazy stuff. But when it comes to a huge amount of data, then you will get an out of memory exception, as always on the Java virtual machine. Okay, let's move on. Last part of the lazy loading stuff is the usage of the new Java 8, a new MicroStream version 8 lazy collections. And this is really straightforward. So let me just change to the step 4 lazy collections. Just cancel this. That's it. So let me just open the documentation for that. You can see that here. That is also lazy loading data, and you will find the lazy collections here. These are the 3 different collections we provide within MicroStream, and the idea behind the scenes is to have some chunks of data, and you will be able to define the item size. So that means, for example, the default constructor uses 1000 items in each segment, and when you stream through those collections, then 2 chunks will be loaded because you have to read the data, and the third one, when you open the third one, the first one will be cleared. So that is the basic functionality behind the scenes. These collections are working basically really great at the moment. So there are some issues at the moment by streaming through that lazy arrays. We are working on that, and you will get a hotfix soon. But you could basically use it, and how to use it is this is an example for that. And normally, I would recommend to use it with the default constructor. That's totally okay. But if you want to add a more advanced functionality, you will be able to define the item size of each chunk. And then you have a second value. And this is the amount of time data will be unloaded. And there are 3 different mechanisms. The first one is timed. And you could define the amount of time in milliseconds to unload a chunk. This is possible. You could say never unload elements. Most of the time that will not make really sense, but nobody knows. And the other thing is, let me just check the default ones. I've read it in the this is time, and let's try to find the default time. Not sure about the default behavior, but I'm not sure if it's handled with the normal default mechanism. So the normal lazy default. So we talked about the 30 minutes and 75% of storage. And I'm not sure about it. I have to ask Florian to be more detailed in that. But yeah, you will be able to adjust this also to create or to define the segment size and to set the time to clear the data. And I'm not sure if it makes sense to have 200 milliseconds. Maybe it makes more sense to keep the data a little bit. If some more persons want to read, you don't have to load and unload the data all the time. It's all about testing. Just find out what is the right configuration for your lazy elements and your lazy arrays. And they're working quite well. So check it out, and it's not really difficult to use them. And it's a really great solution for all that, normal array lists. When you would normally use an array list. But yeah, as I said, you have to keep in mind how many concurrent users do I have, and does it make sense to use lazy loading stuff if if the data should stay in the memory anyway, because everyone needs the data. So then you don't have to use a lazy array list. They can be synchronized, but I would not recommend this. There is no, let's say, there is no synchronized lazy array list, because in that case, synchronized doesn't differ between read and writes, and that's a real big problem, especially for collections. Let's say we have 100 persons just want to read data, and there is only one person which is writing data. You don't have to lock the whole collection all the time, and therefore synchronized doesn't make sense. I would recommend to use the reentrant read-write lock. That makes more sense. There is, in the advanced training, there is one. Let me just show you a small example of that concurrent read-write lock. So it's a class like this, and it differs the read from the writes, and it makes more sense to use this one. But this is a part of the advanced 2 training of the concurrency handling and stuff like that. Okay, when using hash maps, what is the segment related to? It's the not really sure, because it's a new feature. I have to ask, but I think it's the key. So you have a lot of you can have, so that means 1,000 keys per segment, if that answers your question. Let's move on to the last branch. For one solution which I used a lot. So what happened there? Team switch to lazy collections. Okay. This is not what I want to. What happened now? So something went wrong now. So just switch to, this was the lazy collection stuff. Discard changes. Okay. So let me just double check that. This is the domain, person, data root. Okay, so let's close this. And now let's move to team switch to full lazy map. Yeah, that's also a great solution. So mostly in most of the projects, when we have a lot of data and a huge amount of data, this could also be a solution for you to have also a map with string as identifier or as a key. And most of the time we used, for example, the first 4 most important properties of a person to enable, that enables you to search within the keys for the right information when you try to find a person. Then that also enables you to only load a few amount of data, and especially the cached data, or the data which is important to search in. And if you find the right one, you could load the person lazily. The problem on that collection is that you have a huge amount of lazy elements, of lazy objects, and in some points that could be an issue, because of the lazy reference is a little bit more expensive than a normal reference, I would say, and that could also be an issue. But as I said, try it out. many different possibilities to create a data structure with those lazy mechanisms, and just find the right structure for your needs within your project. Okay, a lot of stuff is on that lazy, but I think it's, for most of you, it's understandable, I guess. You will, so the point is, and I think it's the same on the concurrent side. You will get a huge performance with MicroStream, and if you need that, you have to deal with the disadvantages of in-memory aspects, I would say. But it's worth it, and because the performance impact is enormous. So that's for sure. So okay, any questions regarding lazy stuff? Non-lazy objects or lazy? What is a cycle time? Non-lazy objects or lazy objects? Okay, so yeah, that's quite hard to say. It depends on, non-lazy is nothing. It's in memory. It's I would say the fastest access. It's not only because it's in memory. It's more important because there is no data mapping in between. We don't have to migrate, or we don't have to map the data from JSON to a Java object, and therefore it's the fastest way to access data I've ever seen, I would say. And lazy objects, as I said, you have to load it from the hard disk. You have to load it from AWS S3, for example. It depends on many different aspects. So it's hard to say, but non-lazy is definitely much more faster than lazy. Okay, when you then another question: when you create special class, why not implementing read-write locks in an effective way in the accessors mutators? That's a good question. Why not? You could do this. Do it. I think that's another special point by using MicroStream. Just use this stuff. What is available within Java. You can use everything with MicroStream. There are no limitations, and I think that's a huge advantage on the database side. Normally, with all the relational databases, you always create a data structure which fits best to the database. But who cares about that? Who cares about creating a data structure which fits to the database? I need a structure which fits best to my application and give me the biggest advantages on the application needs. And therefore, use whatever you want. Try it out. And if there are some issues, let us know, and we are able to improve that. There is one thing I would say, one limitation I have to say is don't use any third-party objects within MicroStream, because that could lead to an issue. But otherwise, you could use any objects, and there are no limitations on the getter, setter, and as you said, accessors or mutators. It's up to you. Use whatever you want. You could use Lombok also. It's working with it. You could use the new what is the not entities, records. Thank you. Yeah, records. That's a big advantage on MicroStream. Use whatever you want. Okay. So we don't have that much time. Let's move on. There are two topics I want to share with you. one is how to create backups. I think that's important. And another one is how to use legacy type mapping. We only have 30 minutes for that. So let's move on. Let's get into it. To shorten that a little bit, I will skip the presentation. But in the end, you could have those presentations and you will get all the informations to that topics. So let's start with legacy type mapping. So what does that mean? It's all about what happens when my classes are changing. So, and therefore I created one project. Let me share that with you. It's called legacy type mapping. This is the link to the repository. There are 3 different branches in that project. And let's start on the master branch. We are already on it. And let's have a look to the domain object, which is just one author object with 3 different strings: mail, first name, last name. That's all we need. Really straightforward class. Let me just check if the data, yeah, we should. Oh, no, that's the wrong project. Moment. Legacy type mapping. Here we are. Okay. There is no storage. Let's start it. Where is it? Here is it. So, okay. Run as Java application. And as always, I use the authors and create method. You can see the database is initialized, and on the browser you see author successfully created. And let's check it out. Here we have one author in place. Mail, first name, last name, the same what we have within the class. Now let's stop the application and switch the branch and just have a look to these properties here. Let's move the name, or let's rename these properties. So team switch to changes stage 1. That means we changed the mail attribute to mail author, and we changed the name, the last name to name. Let's restart the application and see what happens. Run as Java application. Database. Let's start up the database. Let's call this endpoint again. So, and now you can see what you can see within the console. There is something going on here. MicroStream recognized that there are some changes. So it says, okay, there was one author, and you already knew what that is. That is the type ID of the older author object. So that means there must be an author object before. And here you can see there is another one, a new one, with a new object type ID. So the first one is 69 and the new one is 70. And MicroStream says, okay, there is one property which is called mail, and based on some different properties on the name, on the position within the Java class, the data type, it is a 70% chance that it belongs to mail author. So that means it's just a change of the name. Let's go to the first name. It says, okay, it's the same. It stays the same. It's the same data type. It's the same name, 100%. And we have the same on last name because of the position of the class, the data type, the name. It is a chance of 75% that has changed. And now we can access this with yes. And then the database starts up. And now you could see this is the data we get afterwards. And now you see, let me just change this. And we can see this is the new object type with the object type ID 70 and is shown within the browser. And you see the different, or now it's the same, but when I switch to the first thing, you would see the changes. So that means, so how the legacy type mapping basically works is it's kind of like a versioning. So whenever you change one class, then a new object type is created with some rules, and the rules defines how to migrate from the old object to the new one. And the point is that on all the easy changes, I would say, so let's say renaming or moving a male attribute within the class, for example, changing, let's say, for example, integer to long, for example, all that easy migration chain can be done automatically. And the point is, let's say we have 1,000 authors in our system. When you start up MicroStream, not all the 1,000 objects will be changed at once. It's kind of like when you touch an object, it will be converted to the new version, and then it will show up. So that means during the time, you will have objects that stays on the old version because they are untouched. So they stays on the old version, and there are some that are converted to the new version. And that's why I said it's kind of like a versioning. When we now have a look to the persistence type dictionary, for example, so let's check it out. You will see these two object types. You see there is one which is called 69 author, and there is one with the object type ID 70. And you see the changes in it. And that's great, right? So this is most of the changes. You don't have to care about this. I would not recommend to do this like I did here, because I would recommend to do it step by step. It is much more secure. Of course, you have to create backups of your storage, but basically don't do changes like this. Don't change all the properties at once. Do it step by step. It's much more secure, and most of the stuff can be done automatically. There is one question based on what criteria it calculates the score of the new mapping. It's a heuristic in the background. I would say it's a can't find the right word for it. It's a, just a second. So come on. It's a secret. Yeah, it's a secret. I'm not able to share this with you, but it's a heuristic, and as I said, it is a mix of the position of the property within the Java class, the type of that element, the name itself, how the name changes. There are many different things. And even I did not know all the parts of that heuristic, but it is working really great. So, and just try to, sometimes it's quite hard to create a situation that can't be handled by that heuristic. Heuristic. So it's interesting. So, but there are some issues. What about, for example, let me just clean that up a little bit. So I tried to create a situation which cannot be handled by the heuristic. Give me just a second. So let's switch back to the master branch. This is the the first yeah, exactly. So application, let's start this. Starts up. So then let's create. Oh, come on. So here we are. Let's check all this are empty. Let's create one. Okay, so now there is one author within our database. Okay, and now let's move to the second stage of changes. Let's clean that and say, okay, team switch to stage 2. Let's have a look to the author class. And now you see, okay, that could be challenging. So what happened when we now start MicroStream? The values of mail should go to what property? 2, 3, 4, 5, or 6. That is now that this is one example which is quite challenging for. I'm pretty sure MicroStream would migrate the values to mail_2. But what if we don't want that? So what if we want to have it in mail_6? Then there is another mechanism which comes into play. It's the manual mapping. So you will be able to define a refactoring file, which is down here. So let's open this with the text editor, which looks like this. And this file enables you to decide what should happen of the, it was called mail, right? And the mail attribute should go to mail6. This is what we want to have in the end. So this file enables you to define a specific transfer or migration of the values. So let's check it out. So let me just share the DB class with you. This is just a method to load the refactoring CSV file. And the method provide mapping is used here. So you just have to, and this is also at one point, I already said this, and sometimes you have to use the complicated way to initialize MicroStream. And this is one part to set the refactoring mapping provider. You have to use in this way. So, but let's start up the application to see what happened. So, okay, let's try to load the authors. And then you see now mail6 is our new container, I would say, or new property for the mailing. And here you can see the mapping. So see, this is the new author, 70, the old one. And then you can see the fields. These are new fields. And now you can see this is mapped. This is strictly mapped to mail_6. And all the other stuff is changed by the heuristic. So I didn't get that also the other properties changed. Now you see change from last name to name. So this is a combination of manual mapping and automatic mapping. Okay, so that enables you to use the automatic mapping and also the manual refactoring CSV file, for example. So let me just have a look to the questions. Can you please share the form link to fill in? Sure. This is the link for the registration form. Just fill out if you want to have the video and the presentation, and yeah, certificate, then just fill out the form and you will get an email with all that stuff in it. Okay, the versioning thing is it stored anywhere as history for debugging purpose? Basically, it's stored within the persistent type dictionary, but there is no other place where you can access. Some people ask if they can use this versioning as an audit trail. Maybe there is some. Maybe we can add some functionality for that. It could be a feature in the future, for sure. I could imagine, but yeah, it's not implemented yet. Yes, the greatest question. And if you would like to split a field, that's also great. I would ask you a question. How would you do this with a relational database? How to split a field? And I'm pretty sure it's the same. It's in a way difficult, the same like in MicroStream. So you have to add some additional business logic somewhere to migrate the data. Within a relational database, you have to write SQL to split up something, or you have to use a small JavaScript to migrate the data. But I think it's the same on any database. If you want to migrate the data from a different data type to another, or you want to split up data, you always have to have some business logic in the background. But let me just show you this a little later. Can I set default values for new fields? Of course, you can. So you can use stuff like this, of course. That's quite normal in Java. You should do that. That's yeah. Of course, it's possible. Do that. If any option, do we have any options to version refactoring files so that you can revert back to the older version of the app in the future? That's interesting. No, there is. It's not possible because the refactoring CSV file need to have all the information to. So, for example, let's have a look to the CSV file again. So let's say in that case, we moved mail to mail 6. If we have another change on the mail 6 field, the next entry needs stuff like this, for example. So that means the refactoring file is kind of like a history itself. And whatever you change, it has always to be in the refactoring file itself. There is no possibility to say, okay, let's use the previous one where this line is missing, because MicroStream needs that information to handle all the existing versions before. You remember, or do you remember when it could be the case that if there are some objects which are untouched for a long time, it could be the case that there are several versions in between the newest one, because these objects are untouched. So that means whenever you start the application, it needs a valid refactoring CSV file. And it's not possible to use one which is 3 versions before. Is that, I don't know if I could better explain this, but I think that it makes sense in a way. So to be honest, also in projects in production we have a lot of projects which runs in production for years now with MicroStream. In my opinion, it's in a lot of cases it's not necessary to use that manual refactoring. Most of the time we use the automated version of that. Most of the time we tear down the application, we copy the storage, we do a test run, for example, or we have some testing pods. Then we start up the application, we check if the migration works great and stuff like that, and then we use it as it is. And if there are some changes which needs some special business logic, then we add it to the application. But to be honest, I never used this type of refactoring or migration in production. It's maybe there are some, maybe sometimes it's necessary to use it, but I did not have that case in the past. Okay. One point maybe it could be interesting for you regarding split up last name and first name, for example. What we did in the past, we simply create a new property which is called, let's say, last and last and first, for example. So let's say this is a combination with first name and name, and in that case it could be possible to to use let's create a get and set for this field, and on the getter do stuff like this. So we have to stop the training. So if last and first equals null, for example, then we say last and first equals last. It was just name, right? So name plus and first name, and then we call db dot storage manager dot store this. That could be a proper solution to migrate the data from one field to another. You have to test it for sure, and it has to work properly, but if this could be a proper solution, in my opinion. But it's I always said it's up to you. If it's okay for you to have that, in that case, for me it's okay. Maybe some log entries or do some logging stuff there to see, okay, some elements are transferred to the newer version, then it's okay. This is just a small hint for the question, what about splitting up fields, and for everything there is a solution somewhere. Okay, any questions so far? We have 50 minutes left for the last topic, but I promise you that's an easy topic to create backups. Okay, so close that. Don't save that. I have to revert this anyway. So maybe a small information to the legacy type mapping. When you're creating a project, I would not recommend to use the legacy type mapping during the development time. So that means whenever you change the data structure, just change it and delete the whole database and create just a new one. Because that is much more easy than to handle all the changes during the development process, and before we go to production. So just delete the storage again and just create a proper mock-up strategy to just create data at one click, and you can build up the application again or the data structure again. That makes much more sense than to use the legacy type mapping. So you have to use legacy type mapping when you are in production, but not before. Okay, so let's move on to the last part for today. Let's talk about backup strategies. I created another project again. So let me share the link with you. Backup strategies. Here we are. That's the link. Again, there are some branches in it. Let's start at the continuous backup. So as I said, there are two strategies we provide within MicroStream. The first strategy is kind of like a mirror. So that means let's go to the DB class, and it's really quite easy to use. The only thing you have to do is to add backup. Okay, I see. Okay, so I used the MicroStream XML file. In that case, you have to add this property, backup directory, and you have to define a second directory beside the storage directory. You see, the storage directory is data, and another storage directory is data/backup. And to be honest, that doesn't make sense, because you don't want to have the backup data on the same hardware like the real data, of course, but it's just an example, right? So use a different persistent volume, for example, or use a totally different system like AWS S3, for example. It's definitely possible. But just to enable that mirror, you have to add that property. And when we now start up the application, so just a second. So let's start it. Run as Java application. So there are some books for sure in place. So books, let's say create. Books are successfully created. Let's have a look. So now we have 4 books in it. And when we now have a look to the data structure here, you see this is the data. You have the persistent type dictionary. And this is what I've said. This was the question at the beginning of the training. So where is the persistent type dictionary? So you see, of course it is part of the normal storage. And when we open the backup, you have the same mirror of the data in the backup directory. And I always said it's a mirror, because whenever you write down data to the normal storage, it will automatically also will be written to the mirror. So let's call a store, and the store goes there and there. And so that's the first backup mechanism, quite easy to use. And yes, I would use it in from the beginning of production, because when you enable it before production, you have to delete also the backup again and again, because when it's inconsistent, because you deleted the first one, you also have to delete the backup, of course, because it's no longer consistent. And MicroStream does a check at the beginning, and it checks if the backup is consistent to the storage itself, and if not, it will not start. And yes, it is an independent thread. Yes, it is. So the backup process will get triggered after each store. So when we call a store for an object, for example, as an update, then it goes directly to the mirror also. Each store triggers the mirror. That's the first solution. There are a lot of informations to that backup strategy. Let me just share with you the part of the documentation to see that. Housekeeping, legacy type mapping. Where is it? Storing data. It's configuration, is it? Yeah, you can see backup, and we call it the continuous backup. And yeah, I think just let me share you the link to the. That is the link. There's a lot of information below, especially to the full backup. Oh no, it's not that, but it's. I think it's enough information. Okay, so let's talk about the full backup. So some people would say, okay, a full backup is an easy game. I just create a cron job and copy the files of the storage directly to another system. Is that a good idea? What do you think? No, it's not. Because from outside, yes, it could. So basically, yeah, it could be a corrupt backup. That's right. But we never know if there are some storing behavior in place. So that means when we create the copy, it could be that there is only half of a store is written on the backup. So that means the backup process must be part of the storage engine itself, because so that means we have, let's say we have 10 storing processes or tasks are ongoing, and then we need the backup in the middle, for example. So write the first 5, then comes the backup, and then the next 5 elements are stored. So how to use the full backup mechanism? Let's go to the next branch. Switch to full backup now. And it's, oh, come on, it's not a surprise. It's just one line of code, but you have to take care about how to use it. And most of the time we use the Quartz framework to do the full backup. And I created a small helper method for that. So I use the Micronaut event listener. So that means on startup, on Micronaut startup, it creates the storage backup scheduler. And within that scheduler, we say, okay, let's do a backup. Well, I don't know what this means now, but you can define this by yourself. Let's create a backup every day, or twice a day, or twice a week. It's totally up to you. And the point is, this is the task, or every hour, it's up to you, and say, okay, let's keep only 10 backups, the last 10 backups, and delete delete the oldest in the end. And this is the only line of code you need to have to create a full backup. It's quite easy to have that. You can decide whatever target system you want to have. You could create it. Mostly we write those backups directly to AWS S3, for example. It's totally up to you. But yeah, every hour, right? So thank you. Now I got it. So this is every hour. But I'm not an expert in cron schedule. I have to always read this again and again. So, but that's it. That are the 2 backup strategies we provide at the moment. We have one question. Is there an incremental backup? An incremental, not. So in that case, we have a weekly or a daily backup. I think it's a mix of the continuous and the full backup, but there is no mechanism in place to do that. Yeah, like a history. So no, there is no history in place at the moment. I think you have to do this by your own. So when you create a backup, I say twice a day, then you will keep the last 10 or the last 5 backups. Ah, okay, I see. No, that's not the case. There is no possible functionality in place. Okay. Yeah, it's the same on built-in history. It's not there is no functionality for history within MicroStream, but maybe there are some good frameworks available for that to do that. I think it's the same. Use Java native stuff for doing some history. I remember one framework. What was the name of that? A huge history framework for Java objects. Yeah, the files are incremental. That's right. So that's also an interesting part. It's mostly part of the advanced 2 training. Just to how does the storage work in the background? So we never delete stuff within the storage. So whenever we add or we change, so let's say we have one customer object and we change last name and first name, the whole customer object will be appended to the storage. And this will work again. Everything which changed within the storage will be appended to the binary file. And as I said, there is one housekeeping process in the background. And this housekeeping takes care about to delete the duplicate entries and the old entries of the storage itself. So, and therefore it's, yeah, incremental. Yeah. Yeah. You mean the framework name of the history framework? Okay, what was yeah, I tried. Oh. It's also a quite old one. It exists forever, I guess. So I can't remember the name. But, so I used it once, and it's a quite complex stuff. Envers? No. Can't remember. I have to try to find it out and add it to the mail. Yeah. Okay, so it's 9:00 p.m. So let's try to answer the last questions. And if you have some more questions, feel free to send me a mail. I try to answer all of them. Yes, as I said, the recordings will be available. I share you the link again. Just fill out the form of just a second. Just fill out this form and you will get all the stuff you need, the recordings and also the PDF files of the presentations. Groundhog Guru. Yeah, thanks. That helped definitely. Okay. Yeah, it's also part of within that mail to get a certificate for the training. Yeah. Training in the past, it depends on what training. But let's send me a mail. I think we could do that. Pretty sure. Okay. From normal object to lazy one. I think the migration from list person to lazy list person, it needs some business code. You have to migrate the data manually. So, so if you are in production, if you are already in production, then you have to migrate. If you're not in production, just delete the old structure and create a new one and do some proper mock-up data. Okay. Yes, I took the note, especially for those of you which took part on the fundamentals training. I noted it, and I will forward this to my colleague, and you will get a message. I don't think we have enough time, but maybe when you please stay within the meeting, so I can show you how to import it on GitHub. Yeah, of course. So C dot. So this is my mail address. It could be possible that if I don't have enough time to answer, I will forward this to my colleagues, but that should be okay. And there are some special channels. So we have GitHub discussions and stuff like that. Please use the official channels as often as it is. But if there are some special things you need to know, contact me. That's okay. Okay, so there is a Slack group also available. Oh, I'm not prepared for those questions. I'm only working for the technical stuff. MicroStream. Just check this out on our homepage. There are some community stuff, GitHub discussions, and we are working on a Slack group for MicroStream. It's not available for now, but it will be available soon. Pretty sure. Okay, great. So then last words from my side. Great to have you in that training. I enjoyed it a lot. So hopefully MicroStream helps you a lot and you enjoy working with MicroStream. Yeah. So I would say take care, stay healthy, and it's great to hear from you. So if you have any projects you want to share or you like to share on as a success story or stuff like that, please let us know. And yeah, enjoy. Thanks for joining. See you and bye-bye.